All right, everybody, welcome to another deep dive. You ready to explore some physics with me today?
I am definitely ready. It's a fascinating subject.
Let's jump into the world of forces and motion, specifically. We've got some really interesting concepts that might seem pretty basic at first glance right at a high school physics class, but trust me, they explain like so much about how the universe works.
Absolutely.
We're going to be talking about weight versus mass, the crazy experience of free fall, how forces like friction can really mess with motion, and the legendary Newton's three laws of motion.
It's always fascinating to see how these concepts play out in our daily lives.
Exactly. Like, have you ever thought about, like, why a feather falls slower than a bowling ball? Or, like, how rockets even launch into space?
Yeah, those are questions we get all the time.
Yeah, we're going to unpack all of that and more today.
Yeah.
So first up, let's tackle this whole weight versus mass thing. I know a lot of people get those two confused.
Yeah, it's a common misconception.
Yeah, and our notes here say to use math to compare them. What's the math connection here?
Okay, so let's think about what happens when you step on a scale, right? You're measuring your weight. That's the force of gravity pulling you down.
Okay.
But gravity acts on your mass, which is the amount of matter you're made of. So that mass, it stays the same whether you're on Earth, the moon, or just like floating out in space.
So if my weight changes on the moon, what does that tell us about the nature of weight itself?
That's a great question. It really highlights that weight isn't like this inherent property of an object. It's a force that depends on the gravitational pull of where the object is.
Okay.
Your mass, though, that's constant. It's like your cosmic ID card. It never changes.
Oh, I like that analogy.
Okay.
All right. So on to free fall, our source mentions using models to explain velocity in free fall. But first, what exactly is free fall? It sounds kind of intense.
It is intense. Free fall is when gravity is the only force acting on an object. Like imagine a skydiver jumping out of a plane.
Okay.
For those few seconds before they open their parachute, they're in free fall. Only gravity is acting on them.
Okay, I get free fall now, but how does velocity play into this?
Well, this is where it gets really cool. As an object falls, its velocity or its speed, right, increases at a constant rate because of that pull of gravity.
Hmm.
And this rate of increase is called acceleration due to gravity, and it's about 9.8 meters per second squared near the Earth's surface.
Ooh, okay, slow down there a bit.
Okay, sure. Basically, it means that for every second an object falls, its velocity increases by 9.8 meters per second.
Wait, so a feather and a bowling ball would fall the same rate in a vacuum? That doesn't seem right.
I know it's true in our everyday life. We see heavier things fall faster because of air resistance, which acts as a force opposing the motion.
Right.
But in a vacuum where there's no air to slow things down, that feather and bowling ball, they would plummet side by side and hit the ground at the exact same time.
Yeah, that's mind-blowing.
Yeah.
Okay, moving on. We also have some notes on applied force and friction, and we need to come up with an explanation about the effects of those forces on objects.
Okay, so think about pushing a textbook across your desk.
Okay.
You're applying a push to the book, but it doesn't just zip across the surface, right?
Mm.
Right.
There's friction between the book and the desk, acting in the opposite direction to your push, trying to stop the book's motion.
So a smoother surface means less friction, and it's easier to push the book.
Exactly. And think about different types of surfaces. Pushing that book across a smooth, polished desk is a lot easier than pushing it across a rough carpet. That's because the rough carpet creates more friction.
Right, okay, so this all ties in perfectly with Newton's laws of motion, right? They're like the big three in physics.
They're fundamental to understanding how objects move. The first law, inertia, states that an object at rest stays at rest, and an object in motion stays in motion at a constant velocity unless acted upon by an unbalanced force.
Okay, so if I toss my pen across the room, it would just keep going if gravity and air resistance weren't stopping it.
Exactly. Inertia is an object's tendency to resist changes in its motion. It's why you feel a jolt when a car brakes. Suddenly your body wants to keep moving forward at the same speed.
So that's why seatbelts are so important. They provide that unbalanced force to stop us from continuing to move forward.
What about the second law?
The second law focuses on how forces cause those changes in motion, and it's represented by the equation F equals ma,
Oh yeah, I remember that from physics class.
meaning force equals mass times acceleration.
Right.
So the greater the force applied, the greater the acceleration, but the greater the mass, the smaller the acceleration for the same force.
Okay.
Think about pushing a shopping cart. It's much harder to get a full cart going than an empty one because that full cart has more mass.
Okay, so more mass means more force is needed for the same acceleration.
Yeah.
Got it. What of the third law, the last but not least?
The third law, it states that for every action, there is an equal and opposite reaction.
Okay.
When you jump, you push down on the ground, that's the action. The ground pushes back up on you. That's the reaction, with an equal force propelling you upward.
So forces always come in pairs. I
Yeah.
never thought about it that way before.
Pretty neat.
This has been such a great overview of forces in motion. We learned that weight and mass are totally different things.
Yeah.
Objects fall at the same rate in a vacuum, which is mind-blowing. Forces can cause changes in motion, and Newton's laws govern how objects behave.
It's amazing how these seemingly simple concepts explain so much about the world around us.
It really is. As you go about your day, remember to think about all the forces at play, from the gravity holding you to the earth to the friction that helps you walk for the physics is literally everywhere.
It's true.
Thanks for joining us for this deep dive into forces in motion.
Thanks for having me.
We'll see you next time.
See you later.
Bye.